Welcome back to Aurora Tech Channel. Today, I will review a new engraver from AtomStack, the A24 Pro. This is part of their new generation series, and instead of just making more powerful laser modules, it seems this series focuses more on feature upgrades, better build quality, and other different improvements. The new A6 series starts at $369 for a basic 6-watt and goes all the way up to $609 for a 24-watt, which I will be testing today. It's not the most powerful in the market, but it uses a long beam waist laser that claims to have better cutting power, so I will definitely test that out later. Besides that, it uses a steel wheel motion system on the x-axis and dual linear rods on the y-axis instead of palm wheels like on other budget laser engravers. The working area is slightly smaller than a standard 400 by 400 engraver at just 365 by 305 millimeters. The frame of the machine is a one-piece design instead of a regular frame put together by a few pieces of aluminum extrusions. The frame is very sturdy with a lower center of gravity, so it can work at a much higher speed of 36,000 millimeters per minute. For other features, the alignment uses a cross-type infrared laser instead of a dot, and it has a sensor to stop the machine when unexpected movement is detected. It also has flame detection, an emergency switch, and a safety lock. The B3 enclosure is optional. It comes with a few panels that are fixed onto the frame of the machine. It has a camera at the top for easier alignment and an exhaust fan and ducting for smoke management. When fully enclosed, it's a Class 1 laser. Besides the machine, I will also test the enclosure, as well as other accessories like the air assist pump, rotary roller, and the honeycomb bed. I would like to thank AtomStack for sending us this machine and for sponsoring today's video. With that, let's get started. Generally, most laser engravers require some assembly, but this A24 Pro came in one piece. We have the frame of the machine with a cable chain pre-installed, the laser module, power supply, a gauge for focus setting, some tools, and some cables. First, we need to put the laser module on the x-axis and connect the power supply and a few cables. The air assist pump also came with the machine as a free gift when I recorded this video. The honeycomb bed is an option, but it would definitely improve cutting quality and protect your table. The enclosure is also optional, and unlike traditional tent-style enclosures, the panels are fixed on the frame of the machine. There's also a camera mount at the top of the enclosure. Every time you close the lid, it will stay in the same position. There's also two limit switches to work as a safety feature to stop the machine when the lid is open. I will then connect the Wi-Fi antenna and turn on the machine. The enclosure came with an exhaust fan and ducting, but I will just connect it to my own ducting to exhaust the smoke outside. The Wi-Fi feature only works with a mobile app, so to set it up, select the machine model, and it will then start an access point. Connect your phone to the new AP, go back to the app to enter your home Wi-Fi network information, and after that, you can connect back to your home Wi-Fi, and the machine will also be connected to the same network. Let's do a firmware update before we get started. I will now start by engraving some simple text to make sure the machine is working. And for all other tests, I will use Lightburn, as this kind of mobile app just isn't that useful to me. I will set the size of the text, set the laser focus using the gauge, draw a preview frame, and we can now start the job. Okay, it seems everything is working fine. We will now set up this machine in Lightburn. Just let the software search for the machine, and it should find the Gerbil motherboard. Add the device, give it a name, click Next, and keep all the default settings. As the enclosure came with the camera, I will also calibrate it. This is the exact same process as how you calibrate a DIY webcam in Lightburn, starting with selecting the camera. In this step, we need to use the alignment card that came with the enclosure and put it at a different position and let the camera capture and do some calculations. You just need to move the card and the software will do the rest. Then, it will print some test patterns that will use up nearly the entire workable area. I just placed a few pieces of cardboard as I don't want to waste a large plywood sheet just for this simple calibration. After that, capture the image and we will verify the 4 spots on the screen. This is just like using a mobile document scanner app. You need to select 4 corners for the software to make it a normal document. Try to select the center of the pattern as accurately as possible. Now the calibration is done. I will just draw a few simple geometric shapes to test if the camera is actually working accurately before starting other tests. Okay, as I just randomly placed the cardboard, it's a bit tilted, but the circles at all 4 corners and the text are accurate. I will start with an engraving speed test. I will use the Liper material test feature to engrave some squares from 3000 millimeters per minute to 12,000 millimeters per minute. Just ignore this text as I'm using leftover plywood. For a 24-watt module, I think anything slower than 8,000 millimeters per minute may be too dark. At 12,000 millimeters per minute, we can still see something at a 30% power, so I will make another one from 13,000 to 20,000 millimeters per minute to see what kind of result we can get. I think there's no big difference between 13,000 and 20,000 as these squares are tiny and there's no space for the laser head to accelerate, so we can only see a minimal difference in darkness when the speed is over 12,000 millimeters per minute. Compared to the one from 3K to 12K, the difference is more obvious. Then I will try some cutting, starting from 300 to 700 millimeters per minute. All of them can be cut through completely. Let's see how far we can push this machine. I will do another one from 800 to 1200 millimeters per minute. This time, only the 800 millimeters per minute one can cut through, but not completely. So the fastest cutting speed for this 3mm plywood is around 600 to 700 millimeters per minute. Let's cut some thicker plywood. I have some 5mm plywood from Amazon. Let's try 100 to 500 millimeters per minute and see how fast we can cut 5mm plywood. It seems anything less than 500 milliliters per minute can cut through without issues, but the thickness of these tiles looks less than 5 millimeters. In fact, they're just a little over 4 millimeters, so I will say this machine can cut through 4mm plywood at 400 milliliters per minute or slower in a single pass. I will use the camera to align a ninja star on this leftover plywood. The space is a bit tight, but there is some text here. We can't clearly see it on screen, but I would rather the edges of the ninja star slightly overlap with this text than cut outside this piece of plywood. The result seems very close to what I planned. There's a tiny bit of text here, but the edges of the ninja star look good and the cut is also clean, except for a little burn mark in this area. Next, let's try some photo engraving. The top speed of this machine is 36,000 milliliters per minute, and I don't think using this high speed to engrave on plywood can get any good results, but I will still give it a try. As expected, it looks way too light. If we need to engrave at this high speed on plywood, we need some baking soda water on the surface of the wood to make it easier to darken. I will restart the same job with some baking soda applied. As expected, with baking soda on the surface, the wood can be engraved at 30,000 milliliters per minute. I made another at the same speed with even more baking soda. It looks even darker, so I will try the top speed of 36,000 milliliters per minute and see what kind of result I can get. The bottom didn't have enough baking soda applied, but I think it still looks pretty nice. As I found the maximum x-axis speed in the firmware is set to 50,000 milliliters per minute, I will push it to a speed that is even higher than the manufacturer claims and see what happens. When moving at such a high speed, the machine is still super sturdy, and with enough baking soda applied, I can't see any loss in quality even when engraving at this high speed, and the edges of the photo are still straight. Now, we can engrave images much faster, as when I used a normal 10,000 milliliter per minute speed, this 120 by 100 milliliter picture took almost 16 minutes, but now when engraving at 50,000, it can be done in 7 minutes and 7 seconds. Then, I will engrave a Gryffindor logo on this 1/4-inch walnut solid wood and cut it out. I will use offset fill instead of fill, as I don't want it to engrave line by line like a scanned picture. Instead, I will use offset fill so the laser head will move around to engrave on the wood, just like how humans do when engraving. I will also start the job at the bottom part and see how the camera works when the object isn't directly at the center. After the engraving is done, you can hear the air pump turn on automatically when it starts cutting. This logo was made beautifully. There's some depth in different areas, and it's hard to see on camera, but I prefer this more than just scanning the picture on the wood line by line like engraving a photo. As the object is not placed directly at the center, I can see the job shifted about 1 millimeter to the left, but it doesn't seem too bad as it has minimal or no impact on this job at all. As the laser power is just 24 watts, let's see how it can handle thicker wood cutting. I will cut this 1/2-inch poplar solid wood, starting with 100 milliliters per minute. It cut through completely. Let's try 150 milliliters per minute. This time it almost cut through, but the final 1 millimeter or so still has some points connected. So, it can still cut through 1/2-inch solid wood in one pass, but at a slower speed at 100 milliliters per minute. I will also try some acrylic engraving and cutting. I will engrave an eagle on this 3mm black acrylic and cut it out. Diode laser cuts work on clear objects unless some marking tape is used. The engraving looks good, but the 300 milliliters per minute and 100% power may be a bit too high, so the acrylic bent a little. Then, I will try to engrave a round logo on a round slate using the camera. Normally, this round type of object is hard to align with the preview rectangle drawn by Lightburn without the camera. So, let's see what kind of result we can get. I think the result is good, and it looks pretty centered. The edges of the slate are pretty random, so I'm happy with this result and it's much easier than to align it without a camera. Let's try an even smaller object. I will engrave the same round logo and some text on this aluminum business card with black coating, and we're basically just using the laser to burn the coating off. This small card is also aligned well. When the coat is burned off, you can see the natural color of aluminum. Finally, I will also test out the rotary roller. The kit came with 4 legs to raise the machine, and there are 4 screw holes at each corner, so you can just screw on the legs and lift up the whole machine. The roller will be connected to the front panel, and as I will engrave on a small wooden cylinder, I also need to lift it up a little. When using the roller, the speed has to be set to 2000 milliliters per minute, so I will just set the power to 30%. It seems 30% power is still too much, so I guess using 15 or 20% would work better, but when engraving at a higher power, we can get some depth on the surface. After 20 seconds of light sanding to remove those oil marks, it still looks very nice. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The build quality of this A24 has improved a lot compared to previous generations of AtomStack machines. It no longer uses palm wheels. Instead, it uses steel wheels on the x-axis and linear rods on the y-axis. The upgraded motion system is not only more durable, but also works better for high-speed engraving. 2. The cutting power is strong for a 24-watt laser module, and the longer focal length seems to be working pretty well, as I can cut half-inch solid wood with a single pass at 100 milliliters per minute, even though this should be pretty challenging for most laser modules under 30 watts. 3. It has a lower center of gravity, and as a result, the machine is more stable. The manufacturer claims it can engrave at 36,000 milliliters per minute, but even if I push it to the firmware's limit at 50,000, it actually still works pretty well. Of course, if you need to work at this speed on wood, you need to apply baking soda water on the surface or engrave on materials like paper or cards with coating that can easily burn off. 4. The enclosure is handy. It just connects to the frame of the machine, and it's more compact and has a better appearance than the traditional tent-style enclosure. The enclosure added an extra layer of protection on top of the one on the laser head. As the enclosure is fixed on the frame, the camera mounted at the top won't move, so you can just calibrate it once, which is unlike other add-on cameras that need you to mount an arm to attach to the frame of the machine, so if you bump into it, you need to go through the entire calibration process again. 5. The small details of this machine are well polished. The exhaust fan is powerful, and it's even more powerful than most fans on any enclosure I have tested. The machine comes in one piece with cable pre-installed, so you don't need to go through the frame assembly and connect the belt and all the cables. Now for the cons. 1. The size of the machine is 365 by 305, which is a little smaller than a regular 400 by 400 open frame laser engraver. 2. As the camera is fixed, AtomStack can consider using pre-calibrated parameters. Just let the user have the option to use it right out of the box, as they can always fine-tune the values when they see the actual marks on the workpiece are slightly shifted in one direction or the other. 3. The design of the machine uses the lower center of gravity, which is more stable, but it also comes with some drawbacks. Although it can stabilize the machine and prevent smoke from escaping, it also limits the length of the workpiece, so unless you find something to lift the machine, you may not be able to fit a longer workpiece underneath like you could for a regular open frame engraver. 4. When using the roller, the machine is raised up and it's no longer fully enclosed, resulting in smoke escaping. It would be better to make the legs have some slots and include 4 acrylic panels that fit into the slots to make the lower part of the machine fully enclosed as well. 5. The Wi-Fi module can only be used with the mobile app, which just looks like a skin version of the MKS Laser app, as the features are the exact same, only with a better interface. I won't use the app unless I'm using it to jog the machine, but the problem is you have to open a G-code file in order to bring up the machine control menu, which doesn't make a lot of sense. So, I think AtomStack needs to do a bit more work on their mobile app. In conclusion, this machine is a big leap forward for AtomStack. Having tested several machines from AtomStack in the past, I find that the overall design, build quality, motion system, and attention to detail have all improved in this A24 Pro. The speed is the fastest among open frame engravers I've tested, and it still comes with very good results. If your budget allows it, I think getting the F30 enclosure would be a better option. Both the camera and the exhaust fan included with the enclosure perform well, and it also adds an extra layer of protection to classify this as a Class 1 laser machine. Additionally, the enclosure's appearance is simply better than traditional tent-style enclosures. The only drawbacks of this machine are the slightly smaller working area and the not-so-useful Wi-Fi app. However, if you primarily use Lightburn, this shouldn't be that big of a deal. The performance of this machine still stands out in its level, particularly in terms of sturdiness and speed, surpassing any open frame laser engraver. So, I will award it the title of the best performing open frame laser engraver. This will be the 4th laser engraver to earn my recommendation out of the dozens I've reviewed. For more recommendations on 3D printers, laser engravers, and CNC machines, along with detailed specs comparisons and a price tracker that updates hourly, visit auroratechchannel.com. You can find the link to my website, as well as the link to the AtomStack A24 Pro laser engraver in the description. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.